Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This is a great site for you to practice for your multiple entrance exam as well as regular question paper examinations. So this site is a tool for you to practice for such papers. You have a variety of papers. Their detailed solutions along with the PDFs are available. You can also download our app. The link is available in the description box. So let's start with today's paper. Today we'll be solving CBSE Class 12 Mathematics 2023 Set 1 paper. So let's go. We'll be solving the very first question, belongs to mathematics. Here's question number 1, matrix question. It says if A is given by this 0, 1, 0, 0 matrix, then what is A raised to power 2023? So this seems to be tough, but mind it, it's very easy. So A is given by 0, 1, 0, 0 A square. That's A into A. And that is equal to 0, 1, 0, 0 into 0, 1, 0, 0. And this will be equal to first row, first column. So 0 into 0 plus 1 into 0, first row, second column. So 0 into 1 plus 1 into 0. Second row, first column, 0 into 0 plus 0 into 0. Second row, second column, 0 into 1 plus 0 into 0. That gives you all the zeros. Right. Now, A cube is A square into A. That is equal to 0, 0, 0, 0 into 0, 1, 0, 0. Again, on solving, see, similarly, you'll be solving. Let's go. 0 plus 0, 0 plus 0, 0 plus 0. So everything is got to be 0. Again, this is 0, 0, 0, 0 only. So similarly, you will keep on calculating and you will find out A raised to power 2023 is equal to nothing but the null matrix or 0, 0, 0, 0. That is option C. Hope you understood this. Next is question number 2. If 2054 is equal to P plus Q, where P is the symmetric and Q is a skew symmetric matrix, then Q is equal to, fine, you are given this 2054 is equal to P plus Q, right? Now, for any matrix A, we have A is equal to 1 by 2, A plus A dash plus A. Can I write like this, right? Of course I can. So this is equal to A plus A dash upon 2 plus A minus A dash upon 2. Now, this is the symmetric matrix. That is Q in this case, right? So what do you have Q as? Q is equal to half into A, which is 2054 minus A's transpose, that is given by 2, 0. See, 2 will be here, 0, 0 will be taken here, 5 will be taken here, and 4 will be taken here. Correct? So that's 1 by 2, 2 minus 2, that gives you 0. Minus 5, 5 minus 0, 5. 4 minus 4, 0. So that's going to give me 0 minus 5 by 2, 5 by 2, and 0. That's the value for Q. So we have option, this one, option B as the answer. Hope you got that. Let's move to the next question number 3. Student says a correction in the sum. Actually, here was to be meant to be written skew symmetric matrix, right? Q is the skew symmetric matrix, and also this is a skew symmetric matrix. That's it. Question number 3. If matrix 1 to 1, 2, 3, 1, 3A1 is non-singular matrix which where A belongs to A, then the set A is what? Fine. Let's start with the question. You are given the matrix, let's say this is A matrix 1, 2, 1, 2, 3, 1, and 3A, 1. So I'm saying this is a non-singular matrix if given in the question. So if it is a non-singular matrix, that means determinant of A is not equal to 0. Let's find the determinant of A now. So I hope you know the formula for this. 1 into this whole thing, right? So 1 into 3 into 1 minus A minus 2 into 2 into 1, 2 minus 3 into 1 plus 1 into 2 into A minus 3 into 3. This is not equal to 0. This gives you 3 minus A plus, okay, 4, sorry, minus 4. Let's write it plus 2 only. Okay. So this is equal to 3 minus A minus plus 2 plus 2A minus 9 is equal to 0. This is equal to A minus 4 is equal to, not equal to 0, sorry. That gives you A is not equal to 4, right? So that's it. A is not equal to 4. Then set A is all the real values except not 4. 4 is not included, which means option D is the correct answer. See here, A belongs to A, right? Now such that A belongs to all the real numbers except 4. That's it. So hope you understood this. Next is question number 4. If determinant of A is equal to determinant of K into A, then A is a square matrix of order 2. Sum of all possible values of K is equal to. You are given that determinant of A is equal to this. Now you know one formula. This is equal to K raised to power N into determinant of A, where N is the order of the matrix. So this has, since it's an order 2 matrix, so this is equal to K square into determinant of A. And that's it. Over here, you can say K square determinant of A minus determinant of A is equal to 0. I'll take A determinant common. So, sorry. K square minus 1 is equal to 0. This gives me K minus 1 is equal to 0. K square minus 1 is equal to 0, or K may be equal to 1, or K may be equal to minus 1. So you have to find out in the question sum of all possible values of K. Sum of all possible values of K is equal to minus 1 plus 1, that is 0. So you have option D as the answer. Hope you understood this. Next is question number 5. If d by dx of fx is equal to ax plus b and f of 0 is equal to 0, then fx is equal to. You are given d by dx of fx is equal to a plus b. Let's integrate on both the sides. So integrating on both the sides, this will be equal to fx is equal to, this will become ax squared upon 2 plus bx plus the constant c. Now you know f of 0 is equal to 0. This gives you 0 plus 0 plus c is equal to 0. That means c is equal to 0. So what does the fx becomes? Fx is equal to ax square upon 2 plus bx. That's it. So you have option B as the answer. Hope you got that right. Next is question number 6. Degree of the differential equation sin x plus cos of dy by dx is equal to y square is fine. See, the given differential equation is not a polynomial equation, first of all. Question number 6. Degree of the differential equation sin x plus cos of dy by dx is equal to y square is. So you are given this differential equation here. What is the degree? Degree, you know one thing, it is the highest power of order. Highest power of order. And what is order in this case? It's a first order equation. dy by dx. This is a first order equation. And if we talk about the degree is not defined because this is not a polynomial. And why this is not a polynomial? Because dy by dx stands to be at an angle of cos. Trigonometry, it's an angle for the trigonometric ratio. So this is not defined. This is not a polynomial. We can't take it out. See, whenever you are having the derivatives in log, mod, or in such cos type of things, degree is always not defined. So we have option C as the answer. Hope you got that. Next is question number 7. The integrating factor of the differential equation 1 minus y squared dx by dy plus yx is equal to ay for y lying between -1 and 1 is. Okay. The differential equation is given by 1 minus y squared into dx upon dy plus yx is equal to ay. I can write it like dx upon dy plus y upon 1 minus y square into x is equal to ay. I can write it like this, right? So here I am, yeah. Question number 7, the integrating factor of the differential equation 1 minus y square into dx upon dy plus yx is equal to ay. Your y lies between -1 and 1 is. Okay, I'll start from this equation here itself. I'll divide both the sides by 1 minus y square. So you have dx upon dy plus y upon 1 minus y square into x is equal to a into y upon this. Or simply I'll say like this. So this differential equation is of the form dx upon dy plus p1x is equal to q1, where p1 is y upon 1 minus y square and q1 is a y upon 1 minus y square. Now in this case, the integrating factor is e raised to power integral of y upon 1 minus y square dy. I'll put 1 minus y square is equal to something. Now differentiating both the sides, you have minus 2y dy is equal to dt, or y dy is equal to minus 1 by 2 dt. So this integrating factor becomes e raised to power minus 1 by 2 integral of, and this is dy upon t. Okay, so this is nothing but e raised to power minus 1 by 2 log of t, that is e raised to power log of t raised to power minus 1 by 2. I'm opening the integral, so plus the constant c, right? This is equal to e raised to power log of 1 by root t plus the constant. So this is equal to 1 upon root t plus the constant, or this is t raised to power minus 1 by 2 plus the constant. What is t raised to power minus 1 by 2? Okay, I'll just write from here only 1 upon root of 1 minus y square plus the constant. Fine, so let's check with the options. Okay, the all constant is missing. It's okay. We have option 1 minus y square, right? Option D as the answer. Hope you understood this. Next is question number 8. Unit vector along PQ vector, where the coordinates of P and Q respectively are this and this. So this is a vector problem. You are given the coordinates of P and Q. This is, let's say P, not let's say it's given. And this is Q. So P and Q coordinates are given to you. If I find out the coordinates of PQ vector, they will be given by 4i, 4j, minus 7k, minus 2i plus j minus k. This gives you 4i minus 2i, that's equal to 2i, and 4 minus 1, that is equal to 3j, minus 7 plus 1 plus 6 minus 6k. So this is the vector for PQ. That's it. you have to find out unit vector along this. Those unit vector is given by this 2i plus 3j minus 6k. Hope you understood this. Then let's move to the next question. Question number 8, unit vector along PQ where the coordinates of P and Q are this and this respectively is. First of all, if I say the coordinates of P, so the P vector has the coordinates as P point has the coordinates as in the vector form 2i plus j minus k, and Q has as 4i 4j minus 7k. You have to find out PQ. This will be given by 4i plus 4j minus 7k minus 2i plus j minus k. This will give you 4i minus 2i, that is equal to 2i, plus 4 minus 1, that is 3, and minus 7 plus 1, that is minus 6k. This is the position vector for PQ. You have to find out unit vector along PQ. So unit vector will be given by, first of all, let's find the magnitude of it. So the magnitude is given by 2 square plus 3 square, 2 square plus 3 square plus minus 6 square, which is 4 plus 9 plus 36, that is 49, or that is equal to 7. And unit vector along PQ will be given by, see, this is equal to 2i upon 7 plus 3j upon 7 minus 6k upon 7, which makes option D as the answer. Hope you understood this. Let's move to the next question then. This question number 9, position vector of the midpoint of the line segment A is 3i plus 2j minus 3k. If the position vector of the point A is given by this, then the position vector of B point is. Simply, you are given that AB is the line which is joining the point A, that is given by this vector minus 4k. And there is another point B with the position vector. Let's say this is xi, yj, and zk. So position vector of the midpoint of AB, this position vector of the midpoint is given by 3i plus 2j minus 3k. Right? I think, I hope you are clear about the situation. We have assumed the coordinates of the position vector for B be equal to xi plus yj plus zk. Now it's given midpoint of AB is this. Therefore, 3i plus 2j minus 3k is equal to x2 plus x, or x plus 2 upon 2i plus y plus 3 z minus 4k. So equating, you have x plus 2 upon 2 is equal to 3, y plus 3 upon 2 is equal to 2, z minus 4 upon 2 is equal to minus 3. This gives you x is equal to 4, y equals to 1, and z is equal to minus 2. So the position vector of B becomes, position vector of B is 4i plus j minus 2k. That's it. So we have 4i plus j minus 2k is option B. This is the correct answer. Hope you understood. Next is question number 10. Projection vector of 2i plus 3j on this vector, that is 3i minus 2j, is see, projection vector, projection of A on B is given by the dot product of the two divided by the magnitude of B vector. So here, if I'm having the position vector of this, projection of vector of this on this, then required projection See, first of all, let's discuss what is A and B in this case. So projection of vector this on this. So here A is 2i plus 3j and B is 3i minus 2j. Therefore, the required projection is given by 2i plus 3j multiply 3i minus 2j whole divided by magnitude of B. So this is 3 square plus minus 2 square, which makes it, this is equal to 2 into 3, that is equal to 6, minus 3 into 2, minus 6 upon root of 9 plus 4, which is 0. That's it. You have 0 as the answer. Option A is the correct answer. Hope you understood this question. Let's move to the next question, number 11. Equation of the line which is passing through 1, 1, 1 and parallel to z-axis is. So you have to find out equation of the line which is parallel to 1, 1, 1 and parallel to z-axis. I'll say required equation of line is given by general formula is x minus a upon L, y minus b upon m, and z minus c upon n. Here, a is 1, b is 1, c is 1. All the three are 1. And you are given that the line is parallel to z-axis. Given. Since line is parallel to z-axis, therefore L is equal to 0, m is equal to 0, and n is equal to 1 because x and y, they are going to be 0 because it's parallel to, since it's parallel to x-axis, therefore L, m, they will be 0 and you will have the value of n is equal to 1. So now this equation will become x minus 1 upon 0 is equal to y minus 1 upon 0 is equal to z minus 1 upon 1. That is option D. So you have option D as the answer. Hope you understood this. Next is question number 12. If the sum of numbers obtained on throwing a pair of dice is 9, then the probability that the number obtained on one of the dice is 4 is. Fine. Sum of numbers throwing a pair of dice. That means you are having 2 dice over here. So one you are throwing when 2 dice are thrown, number of probable cases, that is, see, it is equal to 6 into 6, 36. Now, cases when 9 is, sum of 9 is obtained. Sum of 9 is obtained. When will you obtain 9? When the first dice will have a 3, second will have a 6, first will have a 6, second will have a 9. First will have a 6, second will have a 3, first will have a 4, second 5, and first 5 and second 4. So these are the total favorable cases are n of A is equal to 4. So that means the required probability becomes required probability is number of favorable cases upon see one thing. The cases when there is 4 on one of the dice, that is sum is equal to 9. Now the probability that the number obtained on question number 10, if the sum of numbers obtained on throwing a pair of dice is 9, then the probability that the number obtained on one of the dice is 4 is. First of all, you are throwing 2 dice, so total number of cases will be 36, right? And the cases when 9 is obtained. When will you obtain 9? When the first will have a 3, second will have a 6, first 6, second 3, 4, 5, or 5, 4. So the number of such cases when you are having a sum of 9, that is 4, right? So therefore, probability of A to occur is 4 upon 36, 1 to 9. So the probability that you will get a sum of 9 on the dice is 1 by 9. Now, question is probability that the number obtained on one of the dice is 4. Now, the cases when there is 4 on one of dice, when we are having when sum is 9, is, let's say, B. So these are two cases, 4, 5 and 5, 4. So n of B is equal to 2. The probability of B to happen is 2 upon 36, that is 1 upon 18. Okay. You can also write it like N A union A intersection B. See, 4, 5, these two are repeating here as well. So these are two cases, 1 and 2. So the number of cases which occurs in both the cases, that is A intersection B, is 2. And probability of A intersection will be equal to 2 upon 36, that is 1 upon 18 again. Now you have to find out the required probability, which you had to find out was probability of B upon A. That is probability of event B to happen from A. That is given by probability B intersection A, or A intersection B, divided by probability of A. This is equal to 1 by 18, and probability of A was equal to 1 by 9. So this is 1 by 18 into 9 by 1. That is equal to 1 by 2. So you have option D as the answer. Hope you got that. Let's move to the next question, number 13. This is a trigonometric problem. Antiderivative of tan x minus 1 upon tan x plus 1 with respect to x is. So let's say this is equal to some I. I is equal to antiderivative of this. So that means you have to find the integral, that I is equal to tan x minus 1 upon this plus 1. Tan x plus 1 dx. So I'll do what? I'll take minus outside, and this can be written as 1 minus tangent of x upon 1 plus tangent of x dx. That is equal to, minus will be taken. So 1 can be written as tan of pi by 4 minus tangent of this upon 1 plus tangent of pi by 4 into tangent of x dx. You know, that is the formula for tan A minus B. That is given by tan A minus tan B upon 1 plus tangent A into tangent B. So this is the formula for minus integral of tan pi by 4 minus x dx. That is equal to, the integral of tan is log secant pi by 4 minus x I'll rewrite. So that is equal to minus log secant of pi by 4 minus x plus the constant c. So let's check with the options. You have option D as the answer. Hope you got that. Next is question number 14. If AB, B, C, D, E, F are the vertices of the triangle ABC and delta denotes the area of the triangle ABC, then what is this equal? Now, this, and this, let's say this is equal to AB and C. These are the vertices of the triangle ABC. Then the area of the triangle in the matrix form will be given by half the determinant of AB1, CD1, EF1. So you can write down 2 delta is equal to, this can be written as ACE, and here you can write down BDF and 1, 1, 1. I can write it like this. Reason is interchanging rows and columns will not change the determinant. Okay, so I can write it like this. I have multiplied this 2 on the LHS, and at the same time, I have converted the rows into the columns. Okay, fine. So now you have 2 delta is equal to ACE BDF 1, 1, 1. Let's square the both sides. You have 2 delta square is equal to ACE BDF 1, 1, 1 whole square. Or this is equal to 4 delta. This is what you need to find out in the question. ACE BDF 111 whole square is equal to 4 delta square. Option P. Hope you got that. Next is question number 15. The function f(x) is equal to x into, this is mod of x like this, is continuous and differentiable at x is equal to 0, continuous but not differentiable at x is equal to 0, differentiable but not continuous at x is equal to 0, neither differentiable, not continuous at x is equal to 0. So here you have f(x) is equal to x into x mod. For x belonging to the real numbers, the function can be written as fx is equal to, see, this will be x into x for x greater than 0, and this will be x into minus x for x is less than equal to 0. So this is equal to x square for x greater than 0 and minus x square for x less than equal to 0. Now, left hand limit of f of 0 is equal to limit x approaching 0 minus, and this will be, see, when it is left hand limit of x 0, I'll be taking minus x square. So this is minus x square over here, and this is of course 0. And when I'm taking the right hand limit of f of 0, this is equal to limit x approaching 0 plus, and now I'll be considering the positive value, which is x square, which again is 0. This comes out that left hand limit of f is equal to 0 is equal to right hand limit of f is equal to 0 is equal to f0. Therefore, the function is continuous. Is continuous at x is equal to 0. Now, let's find, I'll say the right hand limit of f dash 0. This will be given by limit x approaching 0 plus f of x minus f of 0 divided by x minus 0. So when it is approaching 0 plus, the positive value of x square will be taken. So this is x square minus 0 upon x, or here was limit x approaching 0 plus. So this is equal to 0 itself. Okay. See, actually, this is of the form 0 upon 0. So I will apply first L'Hospital rule. So you will have limit x approaching 0 to x upon 1, which is equal to 0. Okay. That was the right hand limit. Now let's talk about the left hand limit of f dash 0. So limit x approaching 0 minus fx minus f0 upon x minus 0. This will be equal to minus limit x approaching 0 minus x squared 0. This upon this. Right? Okay, this can be written as limit x approaching 0 minus x squared upon x. I do not need to apply the L'Hospital's rule. You can simply cut down. All right, anyways, this is limit x approaching 0 minus x, which is again 0. Therefore, left hand limit of f dash 0 is equal to right hand limit of f dash 0. Therefore, function is differentiable since both of the values are equal. So the function is differentiable at x is equal to 0, which makes it is continuous and differentiable at x is equal to 0. Both are true. Option A is the correct answer. Hope you understood this. Next, question number 16. Tangent of x plus y upon x minus y is equal to k. Then dy by dx is equal to. Okay, you are given that tangent x plus y upon tangent x minus y is equal to k. I can write like tangent x. There is some, sorry. It's not the separate ones like this. Okay, this is equal to k. So x plus y upon x minus y is equal to tangent inverse of k. Now differentiating both the sides with respect to x, we will get denominator square. Denominator will be written here. Numerator derivative. So this is equal to 1 plus dy by dx minus x plus y into derivative 1 minus dy by dx is equal to the derivative of tangent inverse k, right? Tangent inverse k, this is a constant because k is a constant. This becomes x. I'll open up the brackets. This is x minus y, x into x minus y plus x into dy by dx minus y into dy by dx minus x plus x into dy by dx. I'll take like this on the outside, okay? So that we don't have any confusion. Plus y minus y into dy by dx. That is equal to 0 because the denominator will also go away by the cross multiplication type. So you will have the x and x will get cancelled and you will have minus 2y plus 2x dy by dx is equal to 0. Or you have 2x dy by dx is equal to 2y. 2 will cancel. And you have dy by dx is equal to y upon x. That's it. We have option B as the answer. Hope you understood this. Next is question number 17. The objective function z is equal to ax plus by of a LLP has the maximum value 42 at 4,6, the minimum value at 19 at 3,2. Which one of the following is true? Okay. Question number 17, the objective function z is equal to ax plus by of an LPP, that is linear programming problem, has the maximum value 42 at this and minimum value 19 at this. Then which of the following is true? You are given that the objective function is z is equal to ax plus by. Now, according to the question, it has the maximum value at 4,6. So, z is equal to 442 at 4 into a plus 6 into b. And it is equal to 19 at 3a plus 2b. Let's solve that simultaneously. So, I'll multiply this equation with 3. You have 9a plus 6b is equal to 57. Minus, they will cancel. And you will have minus 15 is equal to minus 5a, or a is equal to 5. Sorry, it is 3. So a will be 3 over here. And the value of b will be calculated from here. 19 is equal to 3 into 3, 9 plus 2b, which gives you b is equal to 5. So you got the two values. A is equal to 3, b is equal to 5. That is option C. Hope you got that. Next is question number 18. The corner points of a feasible region of a linear programming problem are 0, 4, 8, 0, 20 upon 20 upon 3 upon 4 upon 3. If z is equal to 30x plus 24y is the objective function, then the maximum value of z minus the minimum value of z is equal to. Fine. So you're having the 4 coordinate points and the objective function is 30x z is equal to 30x plus 24y. Now at the point 0, 4, which is the first one, you have z is equal to 30 into 0 plus 20 into 4, that is 96. At the point z 8, 0, you have z is equal to 30 into 8 plus 24 into 0, that is 240. At the last point, 20 upon 3, 4 upon 3, you have z as 30 into 20 upon 3 plus 24 into 4 upon 3. So this is 10, 8, this is 232. So this is the minimum and this is the maximum value of z. So you had to find out minimum minus maximum, that is 240 minus 96, that is equal to 144. Let's check with the options. We don't have any options over there. So, but the answer is not listed. So E, none of these. Okay. Hope you got that. Next is question number 19, assertion and this reason problem. So I hope you know this thing. Like both assertion and reason are true. On the option A is when both assertion and reason are true, and reason is the correct explanation of assertion. B is when assertion and reason are true, but reason is not the correct explanation of the assertion. C is when the assertion is true and the reason is false, and D is when the assertion is false and reason is true. Okay, so let's pick up the first one, that is maximum value of cos inverse x whole square is pi square. Okay, this is the reason assertion, and the reason is range of the principal value branch of cos inverse x is this. Fine. So when I say the maximum, if I say maximum value of cos inverse is pi at x is is pi at -1. When I say cos, there is an assertion and a reason problem. So assertion A says that maximum value of cos inverse x whole square is pi square, and the reason is range of the principal value branch of cos inverse x is minus pi by 2 to pi by 2. Fine. So the maximum value of cos inverse x, maximum value of cos inverse x is this is pi at x is equal to -1. Right. So the maximum value of cos inverse x whole square will be equal to pi square. That means this assertion is true. And let's check out with the reason. The reason says the range of the principal branch of cos inverse x is this. But the range of principal value branch of cos inverse x is given by 0 to pi. Therefore, this reason is false. That means we have option C as the answer, that the assertion is true, but the reason is false. Next is question number 20. The assertion A, if a line makes an angle alpha, beta, gamma with the positive direction of the coordinate axis, then sine square alpha plus sine square beta plus sine square gamma is equal to 2. And the reason is the sum of squares of the direction cosines of the line is 1. Well, let's check out. See, first of all, I'm considering the reason itself. The sum of square of the direction cosines of a line is 1. You know this one thing, that cos square alpha plus cos square beta plus cos square gamma is equal to 1. That is the direction cosines of these three angles is equal, the sum of square of direction cosines of these three angles is equal to 1. Now cos square alpha can be written as 1 minus sine square alpha, 1 minus sine square beta, 1 minus sine square gamma is equal to 1. This makes 3 minus sine square alpha, sine square beta plus sine square gamma is equal to 1, or you have sine square alpha plus sine square beta plus sine square, here was gamma, is equal to 2. That means both of these, reason and assertion, are true, and the reason is the correct explanation of the assertion, which makes option A to be the correct answer. Hope you understood this as well. Next is question number 21, sorry. Here we have started with the section B. Now this section has very short answer type questions which carry 2 marks each. Let's start with the first one. There is no choice between the two questions. Evaluate sine inverse sine 3 pi by 4 plus cos inverse pi plus tan inverse 1. I'll start with this. So sine inverse, I can write down sine 3 pi by 2 as pi minus pi by 4, right? Plus cos inverse cos x pi plus tangent inverse. 1 can be written tan of pi by 4. You know, tan of pi by 4 is equal to 1, right? So this is equal to sine inverse sine pi minus pi by 4. This is equal to sine pi by 4 plus cos inverse pi. Cos inverse cos of pi will give you pi, and tan inverse tan of pi by 4 is pi by 4. This is equal to pi by 4 plus pi by 4, which is equal to 3 pi by 2. Yeah. Okay. So this is going to give you 3 pi by 2. Actually, this will be 6 pi by 4 upon 4. This will be 6 pi by 4. That will be equal to 3 pi by 2. Right. Now, B option, draw the graph for cos inverse x, where x belongs to -1, 0. You also have to write its range. Okay. So you have to draw the graph for cos inverse x, where x belongs to -1, 0. See, for cos inverse this is pi, and cos inverse of 0 is equal to pi by 2. Cos inverse of 1 is equal to pi, and cos inverse of 0 is equal to pi by 2. Let's draw it on the graph. So these are the coordinate axes. Here I have 1. This is -1 over here, x-axis, y. Okay. So now cos inverse of 1 when sorry, this is -1. Cos inverse of -1 is equal to pi. You can say this is pi over here, and let's say this is equal to pi by 2. So for -1 it is pi, and for this it is 0. That means the graph is something like this, right? That's it. You have this graph, and from here, what is the range of cos inverse x? It's from 0 to pi. That's it. So you have this option. Okay, there's no option. This is only the solution. Okay, there's no particular option given to you. So hope you got this. Next is question number 22. A particle moves along the curve 3y is equal to ax cube plus 1 such that at a point with x coordinate 1, y coordinate is changing twice as fast as x coordinate. You have to find out the value of a. Okay, you are given 3y is equal to ax cube plus 1. The particle is moving along this curve. Let's differentiate it with respect to x. Okay. See, one thing, the dy by dt. Number 22, a particle moves along the curve 3y is equal to ax cube plus 1 such that the point with x coordinate 1, y coordinate is changing twice as fast as x coordinate. You have to find the value of a. Okay, you are given this is the curve 3y is equal to ax cube plus 1. Also, you are given that at x coordinate, that x is equal to 1, y is changing, dy by dt is equal to twice as fast as x coordinate. So that is 2 into dx upon dt. Okay, now let's differentiate this equation with respect to t. Differentiating equation with respect to t, you will have a 3 into dy by dt is equal to 3ax square into dx upon dt plus 0. So this is equal to 3 into 2. I'm filling the value from here. 3 into 2 into dx upon dt is equal to 3ax square into dx upon dt. Dx upon dt, this will cancel and 3 will also cancel. You have 2 is equal to a x square. See, over here at this case, I was taking x is equal to 1, right? At x is equal to 1, this is changing like this. So I will put x is equal to 1, which makes a's value as 2. Okay, that's it. You need to find out the value of a. So a value comes out to be 2, and this is the answer to the question. Hope you understood this. Let's move to the next question. Number 23. If A, B, C are three non-zero unequal vectors such that the dot product of A and B is equal to dot product of A and C, then the angle between A and B minus C is. Okay, I'm given that the dot product of A and B is equal to the dot product of A and C. I can write like this. This is equal to 0. I'm taking the A common now. So A, B minus C is equal to 0. Now this means that either this is equal to 0 or A is perpendicular to this. Then only the dot product will be equal to 0. Okay. If these two vectors, they are perpendicular to each other, then the dot product between them is 0. So this makes B vector is equal to C vector, which is not possible because it is given three non-zero, non-unequal vectors. So this is not true. I will follow this, that A is perpendicular to this and this. You have to find out the angle between them. Therefore, angle between A and B vector minus C vector is equal to 90 degree. That's it. This is the answer to the question. Hope you understood this. Let's move to the next question then. Number 24, find the coordinates of the point on the line x upon 1 is equal to y minus 1 upon 2 is equal to z plus 1 upon 2, which are a distance of root 11 units from the origin. Origin, coordinate 0, 0, 0. So you have to find out the coordinates of the point, which are lying on this line. Okay, so this is the line. X upon 1 is equal to y minus 1 upon 2 is equal to z plus 1 upon 2. Let's say this is equal to some k. This makes x is equal to k, y is 2k plus 1, and z is equal to 2k minus 1. Fine. So the point becomes let's say the point A. So point A becomes k, 2k plus 1 and 2k minus 1. Now distance from the origin is given to be 11 roots. According to the question, I'm following the distance formula now. So distance formula says k minus 0 square plus 2k plus 1 minus 0 square plus 2k minus 1 square is equal to root of 11, or k square plus 4k square plus 1 plus 4k plus 4k square plus 1 minus 4k is equal to this. Root will cancel. Okay. Not cancel. I'll say this is equal to plus minus 11. Okay. So this will cancel out and you have 6k square plus 2 is equal to plus minus 11, or 6k square is equal to plus minus 9. Sorry, this is 4 plus 1. This is 9k square. Okay, I'll write 9k square is equal to plus minus 9, which gives you k square is equal to plus minus 1, or k is going to have the value as plus minus 1. So what we need to find out, you need to find out the coordinates of the point. So point A can have the value as, it was k, 2k plus 1, 2k minus 1. So A can have 1, 3, 1, or minus 1, minus 1, 3. So these are the two possible answers to the question. That's it. Hope you understood. Let's move to the next question, number 25. If y is given by root of ax plus b, then you have to prove that y into d square y upon dx square plus dy upon dx whole square is equal to 0, or you have to solve this question. Let's concentrate on the first part first. Part 1, you are given y is equal to root of ax plus b. Let's find the difference, differentiating both the sides with respect to x. You will have dy by dx is equal to 1 by 2 into this multiplied by a, or that's equal to a upon 2 into this. Correct. Or see, this is equal to y itself. So I can write down dy by dx is equal to a upon 2y, right? Because see, this is equal to like this. And this thing was equal to 1 upon y. So dy upon dx is equal to a upon 2y, or you have y into dy upon dx is equal to a upon 2. Let's differentiate again with respect to x. Differentiating again with respect to x, you have first function into derivative of second plus second function into derivative of first is equal to 0. First function to derivative of second plus second function to derivative of first. This is dy by dx again. Correct. So you have y into d square y upon dx square plus dy upon dx whole square is equal to 0. That's it. You needed to prove this, hence proved. Hope you understood this. Then let's move to the next part, b of it. Fx is equal to ax plus b, where x lies between 0 and 1, and 2x square minus x when x lies between 1 and 2 is a differentiable function in 0, 2. Then what are the values of a and b? Okay. Let's say, let's write fx is equal to ax plus b when x is between 0 and 1, and that is 2x square minus x when x lies between 1 and 2. Now, left-hand derivative at x is equal to 1. Limit x approaching 1 minus fx minus f1 upon x minus 1 is equal to, this can be written as limit h approaching 0, f of 1 minus h minus f of 1, 1 minus h minus 1. See, when h is approaching 0, this will be written as, x will be written as 1 minus h. Okay. So further, this is equal to limit h approaching 0. Now I'll be taking the first because x is lying between 0 and 1. So I'll be taking the first function. This will be a into 1 minus h plus b minus a plus b whole divided by minus h. That is equal to limit h approaching 0, a minus ah plus b minus a minus b whole divided by minus h, which makes it limit h approaching 0, ab upon h, and sorry, ah upon h. Yeah. So h will cancel and you will have a over here. So this is the left-hand derivative. Let's find out the right-hand derivative at x is equal to 1. This makes limit x approaching 1 plus fx minus f1 upon x minus 1. This is equal to limit h approaching 0. So now this is h approaching 0 for 1 plus. Now this will be f of 1 plus h minus f of 1 upon x minus 1. So that is equal to limit h approaching 0, f of 1 plus h. Now I'll be considering the second function, which was 2x square minus x. So this is equal to 2x square. X in this case is 1 plus h minus x minus This is 2 minus 1, because when I'm putting x is equal to 1 into x square minus x, I'll get 2 minus 1 only. Okay. Whole divided by 1 plus h minus 1. So this becomes limit h to 0. I'll open the brackets. You have 2 into 1 plus h square plus 2h minus 1 minus h minus 1. Whole divided by h. So this is limit h approaching 0, 2 plus 2h square plus 4h minus h minus 2 whole divided by h. These two will cancel and you are left with the limit h approaching 0, 2h square plus 3h whole divided by h, that is limit h approaching 0 to h plus 3, and this will be equal to 3. So it is given in the question that this is differentiable function between 0 to 2. Then what are the values of a and b? Now it is given that the function is differentiable. So left hand derivative at x is equal to 1 is right hand derivative at x is equal to 1, which makes a is equal to 3. Right? So we got the value of a. Now what about the value of b? We need to find out. This is number 1. We got the value of a. Now let's go on to solve for b. Now I'll talk about the left hand limit at of the function fx. So this is equal to limit x approaching 1 minus f of x. This is equal to limit h approaching 0, f of 1 minus s, 1 minus h, which is limit h approaching 0. So over here, I'll consider the function as this one, 2x square minus x, because now I'm considering the function between 1 and 2. Correct. So this is 2x square. X in this case was 1 minus h. Limit h approaching 0. This is a into 1 minus h plus b. See, this is for 1 minus, over here, yeah. 1 minus, I'll be considering the ax plus b, and for 1 plus, I will be considering 2x minus x. Okay. So this is a into 1 minus h upon b. This gives me limit h approaching 0, a minus ah plus b. A was already equal to 3. So this can be written as, this will be 0, a minus b only, right? Plus b, Now the right hand limit of fx is equal to limit x approaching 1 plus fx. So this is equal to limit h approaching 0, f of 1 plus h. This is equal to limit h approaching 0. Now I'll be considering the function fx is equal to 2x square minus x. Why? Because it is greater than 1 now. Right. So this becomes 2 into 1 plus h whole square minus this minus, 2x square minus x. So this is equal to, only this. Fine. This is limit h approaching 0. 2 into 1 plus h square plus 2h minus 1 minus h. Limit h approaching 0 to plus 2h square plus 4h minus 1 minus h. This gives you limit h approaching 0. This is, see, okay, I'll just write down. This is 0, this is 0, this is 0. So 2 minus 1, that is equal to 1. Now the function is over here. You have the left hand limit is equal to right hand limit, because it is given that the function is differentiable between this. So left hand limit is equal to right hand limit, which gives me a plus b is equal to 1. We already had the value of a as this. So B comes out to be -2. You got the two values. We got the A value as 3 and B value as -2. And here we have option. Okay, not option. A's value is 3 and B's value is -2. This is the answer to the question. Hope you understood this. Next is question number 26. So in question number 26, we have started with section C now, which is carrying 3 marks each. So first question, evaluate integral of 0 to pi by 4 log 1 plus tan x dx is equal to. Fine, let's say this is equal to some integral I. I'll be using a property over here. I'm using property that is integral of 0 to a f of x is equal to integral of 0 to a f of a minus f x. So this integral, the given one, 0 to pi by 4 log 1 plus tangent of x dx can be written as 0 to pi by 4 log 1 plus tangent of pi by 4 minus x dx. That is equal to integral of 0 to pi by 4 log 1 plus, I'll open this tangent now. So this is tan pi by 4 minus tangent of x upon 1 plus tangent pi by 4 into tangent of x dx. That was equal to the I. So this is log integral 0 to pi by 4 log 1 plus 1 minus tan x 1 plus tan x dx. This is integral 0 to pi by 4 log, see 1 plus tan x plus 1 minus tan x, that will be 2 upon 1 plus tan x dx. So this is equal to integral pi 0 to pi by 4 log 2 minus integral 0 to pi by 4 log 1 plus tangent of x dx, right? Let's say this is equation 2 and let's say this is equation 1. Okay, so I'm adding this 1 and 2. Adding 1 and 2. So you have 2I is equal to integral 0 to pi by 4. See, these one will cancel and you will be only left with, okay, let's write down log 1 plus tangent x dx plus integral 0 to pi by 4 log 2 dx minus 0 to pi by 4 log 1 plus tangent of x dx. You have integral log 2 into dx, that is equal to 2I, or I will be equal to log 2. This is a constant, so this is integral. This can be written as a 0 to pi by 4 log 2 1 into dx. So this becomes log 2 into pi by 4 minus 0, or I is equal to log 2 by into pi by 8. So pi by 8 into log 2, this is the value of the integral. That's it. So option A, question A answer is pi by 8 log of 2. Hope you understood this, right? Then let's move to the second part of the question. I have to erase the whole question because of the problem of the space. So B part. Find dx upon root of sine cube x cos a x minus a is equal to. Fine. Let's say this is again equal to I, right? And this further is equal to integral of, I can write it like dx upon root of sine raised to power 4x upon sine x into cos x, cos alpha, this is alpha, minus, sorry, this is plus sine x, sine alpha. Okay, so that is equal to dx upon root of see, one thing is there. I will not write root like this. Sine raised to power 4x. I will take the root of it. So this is sine square x into root of. Now this sign I have adjusted. This will be written as cot x into cos alpha plus sine alpha. Or this is equal to integral of cosecant square x dx upon root of cot x, cot alpha plus sine alpha. Now I'll say let cot x cos alpha plus sine alpha is equal to t. Let's find derivative. So dt can be written as minus cosecant square x into cos alpha into dx. So the integral now will become minus of dt upon root of cos alpha into root of t. That is equal to minus this minus 2 root t upon cos alpha plus the constant c. I have opened the integral. Okay. So that is it. Now this is equal to 2 minus 2. T was equal to cot x cos alpha plus sine alpha divided by cos alpha plus c. Or this is equal to minus 2 secant alpha. I'm taking cos on the numerator. So secant alpha root of cot x cos alpha plus sine alpha plus c. So that's it. This is the answer to the question. Hope you understood this. Then let's move to the next question, number 27. You have to find the integral of e raised to power cot inverse x 1 minus x plus x squared upon 1 plus x squared dx. Okay. So again, let's say this is equal to I. So I is equal to e raised to power cot inverse x, this dx. Now I'll put cot inverse x is equal to t, or x will be equal to cot t, where dx will be given by minus cosecant square t dt. So this integral is e raised to power t into, I can write it like 1 plus cot square t minus cot t divided by 1 plus cot square t into minus cosecant square t dt. I hope you're getting this right. I have filled in the value of x as cot t in this equation at every place. Okay. So now this integral I becomes minus e raised to power t cosecant 1 plus cot square is equal to cosecant 1 plus cot square theta is equal to cosecant square theta. So this is equal to cosecant square t minus cot t divided by 1 plus cot t. I will again write it as cosecant square t only into cosecant square t into dt. They will cancel and you will have I is equal to integral of e raised to power t cot t minus cosecant square t dt. Now I'll put the function ft as this cot t. So the derivative of this function is equal to minus cosecant square t, right? So see, if I look at this integral, this is equal to integral of e raised to power t function plus its derivative, right? And you know this, when you have a function cot t and its derivative, they both are adding to each other, this will be equal to e raised to power t into ft, because the integral of the function plus its derivative is equal to the function itself. Okay, so this is equal to e raised to power t into ft plus the constant c. Now let's fill in the value. You have the t as e raised to power cot inverse x, and f of t, that was equal to cot of t. This gives you cot of cot inverse x plus c, right? See, f of t was equal to cot a, right? Cot t, and cot t was equal to cot inverse x. So f of t can be written as this, correct? This gives you e raised to power cot inverse x into x plus c, or let's write it properly. You have x into e raised to power cot inverse x plus c as the answer. Hope you understood this. Let's move to the next question then. Question number 28, you have to evaluate this integral from log root 2 to log root 3. 1 upon e raised to power x plus e raised to power minus x into e raised to power x minus e raised to power minus x. Fine. Let's start with saying it I. So this is equal to I will write it as like I is equal to log root 2 to log root 3. 1 upon e raised to power x plus this minus this. So that is equal to log root 2 this, and see, I'll be taking this e raised to power x as the LCM. 1 upon e raised to power x as LCM. This is e raised to power 2x plus 1 plus e raised to power 2x minus 1 into dx. Okay. Wait. Sorry. I have done this mistake. Okay. So this is equal to e raised to power 2x plus 1 upon ex. They are actually in the multiplication form, not in the addition form. And this is e raised to power 2x minus 1 upon ex dx. That is equal to log root 2 log root 3 e raised to power x into e raised to power x will be taken here, and e raised to power 2x plus 1 e raised to power 2x minus 1 dx. That becomes log root 2 log root 3 e raised to power 2x. This is a plus b into a minus b, which is a square minus b square, like this. Hope you understood till here. Now I'll put e raised to power 2x is equal to some t. Let's find the derivative. So 2 into e raised to power 2x dx is equal to dt. Also, see, when you are putting the e raised to power 2x is equal to t, the limits will also change. This will be, see, when x is equal to log of root 2, e raised to power 2x will be equal to e raised to power 2 log root 2, or this will be equal to log 2 only. Similarly, for the upper limit, it will be log 3. Log 3, only 2 and 3. Okay. Because e raised to power, this is e raised to power log of root 2 square, which is 2. So this is equal to 2. And similarly, the upper limit, that is log root 3, will be shifted to 3. Now, this becomes limit 2 to 3 dt upon 2 into t square minus 1, which is equal to 1 by 2 will be taken outside. Limit 2 to 3 dt upon t square minus 1 square, which is a plus b form. So that is 1 by 2 into. This can be written as, first let it be like this only. Limits 2 to 3. This can be written as 1 plus this into this dt. Now, you know one thing, I'll discuss one formula. Integral of 1 upon t squared minus 1 dt is given by half natural log of t minus 1 minus natural log of t plus 1 plus the constant c. So I'm using this formula in this question. This is half into log of t minus 1 upon c. This minus, this can be written as log of t minus 1 upon t plus 1 plus c. So this plus c limits are from 2 to 3. So this is equal to 1 by 4 log of 3 minus 1 upon 3 plus 1 minus log of 2 minus 1 upon 2 plus 1 plus the constant c. This is 1 by 4 log of 2 upon 4, which is log of 1 by 2 plus log of 3 plus c. Log 1 by 4, this is log 1 by 2 divided by 3 divided by, log 1 by 2. Sorry, here is minus, so 1 by 3. Yeah, sorry, this is mistake. This is supposed to be 1 by 3. So log 1 by 2 divided by 1 by 3 plus constant, that is 1 by 4 log of 1 by 2 into 3. This is log 3 by 2 plus the constant. Right, so this is answer to the question 1 by 4 log 3 by 2 plus constant. Okay, hope you understood this. Next is question number 29. Find the general solution of the differential equation xy minus x square dy is equal to y square upon y square dx. Okay, there are two problems in the question. Let's solve. I'll go with the A part first. So let's write A part properly. You're given xy minus x square dy is equal to y square dx. You can write down dy by dx is equal to y square upon xy minus x square. Now, the given equation is a homogeneous equation. It's a homogeneous equation. So I'm putting y is equal to vx, which will give me dy by dx is equal to first function derivative of second plus second function into derivative of first. I'll say this as equation 1. Now from equation 1, you have v plus x into, you have v plus x into dv by dx is equal to y square upon this, and y was equal to vx. So this is equal to xy minus x square, v plus x into this. This gives you dv by dx into x is equal to v square x square upon xy minus x square minus v. That is equal to v square x square minus v into xy minus x square upon this. Question number 29. Students, before starting with this question, here's a quick reminder to visit our website www.examsnet.com. To practice many more entrance exam question papers similar to this one, you can also download our app. The link is available in the description box. Here we go with the question number 29. We have to find the general solution of the differential equation this. So let's write it down. We'll solve b later. The first equation is given by xy minus x square into dy is equal to y square into dx. This is multiplied. So dy by dx can be written as y square upon xy minus x square. Right, now this is a homogeneous equation. That means we can now put y is equal to vx, which will give me dy by dx is equal to first function to derivative of second plus second function to derivative of first. So you have v plus x into dv by dx. Okay. So now dy by dx from this equation, you have v plus x into dv by dx square is equal to, sorry, dv by dx is equal to y square upon xy minus x square. So this is v plus x into dv by dx is equal to, this can be written as v square x square upon x into v into x minus x square, which is v square x square upon v into x square minus x square. Or you can write it as v plus x into dv by dx is equal to v square upon v minus 1, right? So next, x into dv by dx is equal to v square upon v minus 1 minus v, which is equal to v square minus v square plus 1 upon v minus 1, or x dv by dx is equal to 1 upon v minus 1. Correct? Now let's, you can write it as, see over here, wait, fine. So this is equal to v, oh sorry, this is v, not 1, yes. So now dx upon dv can be written as v minus 1 upon v into 1 by x, right? Reciprocating both the sides. So you have here, I'll take 1 by x into dx is equal to v minus 1 upon v into dv. Let's integrate on both the sides now. So integrating on both the sides will give you, this is equal to log of x plus c is equal to, this is integral of 1 minus 1 upon v. So it can be written like this. So this is log of x plus c is equal to v minus log of v. Or v was equal to, see, you had y is equal to vx. So v was equal to y upon x. So log x plus c is equal to y upon x minus log y upon x. Or let's write it in the proper form. You will have y upon x minus log of y upon x minus log of x is equal to c. This is the required equation and answer to our question. Right? Hope you understood this. Let's move to the second part of the question, which is given by this. For that, I have to erase the whole screen. So B part says x squared plus 1 dy by dx plus 2xy is equal to this. Now, you can write down dy by dx plus 2x upon x squared plus 1 into y is equal to root of x squared plus 4 upon root of x squared plus 1 square. Sorry, not this. Wait. I'll rewrite it again. Dy by dx. I'm dividing both the sides by x squared plus 1 now. Okay. So this is equal to 2x upon x squared plus 1 into y is equal to root of x squared plus 4 upon x squared plus 1. Now this is of the form dy by dx plus py is equal to q, where this is p and this is equal to q. So the integrating factor is equal to e raised to power p dx, that is equal to e raised to power integral of 2x upon x square plus 1 into dx. I will put x square plus 1 is equal to t, which makes 2x dx is equal to dt. So the integrating factor now will become e raised to power dt upon t. That is equal to e raised to power log of t, which gives you t, and t was equal to x squared plus 1. Now the general equation is given as integrating factor y is equal to integrating factor q plus c. So x square plus 1 into y is equal to integral of this into q. Q was equal to root of x square plus 4 upon x square plus 1 dx plus c. They will cancel and you have x square plus 1 into y is integral of x square plus 4 dx plus c, or x square plus 1y is equal to integral of, this can be written as x square plus 2 square dx plus c. So this becomes x square plus 1 y is equal to this is equal to c, x by 2 root of x square plus 4 plus 4 by 2 log of x plus root of x square plus 4 plus the constant c. So x square plus 1 y is equal to x upon 2 into root of x square plus 4 plus this would be 2 log of x into x square plus 4 plus the constant c. Right? Hope you understood. Here is a 2x also there. So this is the required general solution of the given equation and answer to the question. Hope you got that. Let's move to the next question then. So B part of the question says find the general solution of the differential equation x square plus 1 dy by dx plus 2xy is equal to root of x squared plus 4. I'll do one thing. I'll start from here only, and dividing both sides by x square plus 1 will give you dx by dy plus 2x upon x square plus 1 into y is equal to root of x square plus 4 divided by x square plus 1. So this is of the form dy by dx plus py is equal to some q, where this is your q and this represents p. So the integrating factor becomes e raised to power p into dx, that is equal to e raised to power 2x upon x square plus 1. Dx, I'll put x square plus 1 is equal to t. Which gives me 2x. Dx is equal to dt. So the integrating factor from here becomes e raised to power dt upon t, which is equal to e raised to power log of t. That is equal to t, and t was equal to x squared plus 1, which means integrating factor is equal to x squared plus 1. Now the general solution will be given by integrating factor into y, integrating factor into y is equal to integral of integrating factor into q dx plus c. This was equal to x square plus 1, y is equal to x square plus 1 into q was equal to root of x square plus 4 divided by this into dx plus c. This will cancel and you will have x square plus 1 into y is equal to root of x square plus 4 dx plus c. So x square plus 1 y is equal to, this can be written as x square plus 2 square dx plus c. See, now when you're having x square plus 2, this is having a general formula. Let's discuss that. Integral of root of x square plus a square is given by, this is given by x by 2. I'll directly write it over here. Okay, so this is given by root of x square plus a square plus a square upon 2 multiplied by log of, I'll write log here. So multiplied by log of x plus root of x square plus a square plus c. Okay, so I'll use the same formula. This was the integral, and I'll use the same formula. This will be written as x square plus 1 into y is equal to x by 2 root of x square plus 4 plus 4 by 2 log of integral of x plus this plus the constant c. So this will be written as x by 2 root of x square plus 4 plus 2 log x plus root x square plus 4 plus c. Here's a correction. This bracket was here, not at this place. Okay. So this is the required general solution of the differential equation. Required general solution of given differential equation. That is x by 2 root of x square plus 4 plus 2 log x plus root of x square plus 4 plus c. So this is the answer to the question. I hope you understood this well. Let's move to the next question. Question number 30. Two balls are drawn at random one by one with replacement from an urn containing equal number of red balls and green balls. You have to find the probability distribution of number of red balls. Also find the mean of the random variable. Okay. See, two balls are drawn at random one by one with replacement from an urn. So when we draw, here's we're solving question number A. When we draw two balls, we get either no red ball, one red ball, or two red balls, right? Then the probable or possible values of x are 0, 1, and 2. Now suppose the number of red balls is x, is y. X we have already used. So let the number of red balls is equal to y. So green balls are also equal to y. So total balls are, see, red and green, they were equal. It's given in the question. Total balls is equal to y plus y, that is equal to 2y. Now the probability that you draw a 0 red ball is given by px is equal to 0, or the probability of no red ball. That means you are drawing both the balls as green. This is given by y upon 2y multiply second ball also y from 2y. That is equal to 1 by 4. Similarly, when probability that you are withdrawing one red ball, that is the probability of red green or probability of green red, right? So this is given by y upon 2y into, again they are the same ball, so y upon 2y plus y upon 2y multiply by y upon 2y, which is 1 plus 4 by 1 plus 4, that is equal to 1 by 2. Now the probability that you withdraw both the balls are red, that x is equal to 2. Probability of two red balls is equal to probability r, and that is y upon 2y multiply y upon 2y, which is 1 by 4. So let's make the probability distribution. So the probability distribution is given by x is equal to 0, 1, 2, and the probability of x event is for 0 it was 1 by 4, for 1 it is 1 by 2, and for this is 1 by 4 again. Now you have to find the mean, that is summation of xpx, that is given by see, let's multiply. This is 0 into 1 by 4 plus 1 into 1 by 2 plus 2 into 1 by 4. That is equal to 0. This is multiply, right? 1 by 2 plus 1 by 2, or that is equal to 1. So the answer to the question is find the mean of the random variable. This is equal to 1. And you have to find the probability distribution of number of red balls. That is also given over here. This is the one. Hope you understood this. Let's move to the next question, number 31. Sorry, we have to solve the B part as well. I missed that. B part says A and B throw a die alternatively till one of them gets a 6 and wins the game. Find their respective probabilities of winning if A starts the game first. Okay. First of all, let S denote the success. What do you mean by that? It is getting a 6. Now, A and B throw a die alternatively till one of them gets a 6. So, 6 represents the success, and I'm representing that success by S. And F, the failure. F denote the failure. And what are the failure cases? That is not getting a 6. Not 6. Or you can say this is 1, 2, 3, 4, and 5. These are the 5 cases for the failure. Thus, probability of S to happen is 1 out of 6 because this when you throw a dice, there are 6 outcomes. So this is 1 outcome out of those 6 outcomes. And the probability of getting a failure is equal to 5 by 6 because these are 5 outcomes and 6 is a total outcome. Okay. So this is given by the P, that is the probability, the favorable cases probability, and this is the negative probability. That is not like negative probability. That's not even happening. So now, what the question was, find the respective probabilities of winning if A starts the game. Now, if A starts the game, the probability A wins in the first throw is equal to this. Now, after that, B will throw up, right? So suppose A doesn't win in the first throw, then B throws up and B doesn't win. So probability A wins in the second throw is given by. So in the first case, he'll have a failure. Second case, if C, B wins. So second case also he gets a failure. Sorry, third throw. So then a success. So this is given by Q into P. Similarly, probability wins in the fifth throw is probability failure, success. That is equal to Q, and P. So probability A wins is given by, if you look at this, this is given by P plus this is equal to Q squared P. This is equal to Q raised to power 4P. So Q squared P, Q raised to power 4P, and so on. I'll take P common. This will be 1 plus Q square, Q raised to power 4, so on. So now this is a GP, where the first term is 1 and first term is not 1, first term is P. Okay. First term is P and the common ratio is equal to Q square. Right? So this is equal to, I've taken P the outside. So it will be, I'll take it 1. Okay. So P into 1 upon, this is an infinite series. So 1 minus, see the formula is for the GP for infinite series. It is A upon 1 minus R. A in this case is 1 and R is Q square. So this is this. That is equal to P upon 1 minus Q square. Correct? So what is P? 1 upon 6. Q is 5 upon 6 square. This is equal to 1 by 6 upon 1 minus 25 upon 36. That is equal to 1 by 6 upon 36 minus 25 upon 36. That is equal to 1 by 6 upon 11 upon 36, or this is gonna give me 6 upon 11. Right. Now this is the probability that A wins. Probability B wins. simple. 1 minus x upon 11, which is equal to 5 upon 11. Right. So the probability B when A wins is 6 by 11. Probability B wins is 5 by 11. That's it. You have answered this for the B part of the question. So whichever you feel easy, you may follow that. Let's move next. Question number 31. Solve the following linear programming problem graphically. Okay, you have the minimize z is the objective function is given by 5x plus 10y subject to constants this, and this, where x is greater than 0, y is greater than 0. Here you have the objective function as z is equal to 5x plus 10y subject to constraints x plus 2y is less than equal to 120, x plus y is greater than 60, and x minus 2y is greater than 0. Right. So let's go for the corner points. X plus y is greater than equal to 60 and x minus 2y is greater than equal to 0. Now changing inequalities to equations, you get the three equations as x minus x plus 2y is equal to 120. Let's make the table for this. So here you have x and y. If I put x is equal to 0 and y is equal to 0, if I put x is equal to 0, you will get y is equal to 60. And for y is equal to 0, x is equal to 120. Let's go for the second equation. X plus y is equal to 60. Changing this equality to equation, you have here is x, y. If I'm putting x is equal to 0, y is 60 and y is equal to 0, x becomes 60. Next, the last one is x minus 2y is equal to 0. Let's frame the table for that also. So here is the table, this one, this. So this is x and y. If I'm putting x is equal to 0, y becomes 0. If I'm putting the x is equal to 120, y becomes 60. So let's say this is number 1, number 2, and number 3. Okay. Now, solving 1 and 2, we get the point of intersection. As this is the point of intersection, both of them. And solving 2 and 3, point of intersection is, see, there is no as such point of intersection, but when you will solve x plus y is equal to 60 and x minus 2y is equal to 0, you will get the point of intersection for the two to be 40, 20. Similarly, solving 1 and 3, point of intersection as 60, 30. Okay. Yeah. Fine. Right. So let's plot the graph. We have the points now. Let's plot the graph for this. So we have the 3 points as 0, 60, 40, 20, and 60, 30. Okay. First of all, let's plot the points according to the lines which are given to us. This is the coordinate axis. So wait, this is the coordinate axis, correct? So the point for the x plus 2y is equal to 120. I'm plotting the points for that. And the points were 0, 60 and 120, 0. So first of all, let's mark it over here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 120. Let's mark. So this is 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 140, 150. Similarly, 10, 20, 40, 60, 70, 80, 90, 100, 10, 20, 130, 140, and so on. Okay. Fine. So for every first points were 0, comma 60. 0, comma 60 is this point. And then 120, comma 0. So this is the second point. Let's join these 2 points very carefully now. So this is the line. Give me a minute. Let's join these points. You have this line. This line is x plus 2y is equal to 120. Let's go with the second line. X plus y is equal to 60. So the 2 points are 0, comma 60, which is again the same point, 0, comma 60, and 60, comma 0, which is this point. So let's join these 2 points now. This is the second one. This line is x plus y is equal to 60. Next one, x minus 2y is equal to 0. So the first point is the origin, that is 0, 0. And the second one is 120, comma 60. So 120, comma 60 will be here. Over here somewhere, right? So this is the third line. It's got to be a straight line actually. So this is x minus 2y is equal to 0. This is the line. Fine. So we got the region. This is one. All right. So now the corner points, we got the corner points as, let's write down. Let's mark the corner points first. This point is one of the corner points. Let's say this is 60 and 30. Okay, when you will see this comes out to be 60 and 30. My markings are not precise because I'm not using the graph paper. And this point is 40, comma 20. This is 60, comma 0. And this is 120, comma 0. Let's say this is A. Let's say this is B, C, and D point, right? Now you have the corner points as, I'll go with the first one, A, 120, comma 0, and objective function was z is equal to 5x plus 10y. So this becomes z is equal to 5 into 120 plus 10 into 0, that is equal to 600. And B point is 60, comma 30. So z becomes equal to 5 into 60 plus 10 into 30, which is 600 again. For the third point, C, 40, comma 20, you have z is equal to 5 into 40 plus 10 into 20, which is 400. And for the last, that is a T point, 60, comma 0, z is equal to 5 into 60 plus 10 into 0, which is equal to 300. So out of this is the minimum value, right? And what do you have to find out in the question? Let's look. Minimize. So I have to find out the minimum value. So minimum value of z is 300. Minimum value z is equal to 300 when x is 60, y is 0, and this is the answer. Hope you understood this question. Let's move to the next question, number 32. So now we are starting with section D. This section comprises of long answer type questions, and these questions carry 5 marks each. Let's go. So if A is this matrix, B is this matrix, you have to find A, B and use it to solve the following system of equations this. Or the second part, you have to solve this question. I'll go with the first question first. So you are given that I'll start here. A matrix is minus A matrix is minus 3, minus 2, minus 4, 2, 1, 2, 2, 1, 3, and B is 1, 2, 0, minus 2, minus 1, minus 2, 0, minus 1, and 1. Let's solve AB. You know, that's first row, first column. So this is minus 3 into 1. I'll just write it directly, okay? Minus 3 into 1, minus 3, minus 2, minus 2, plus 4. And this is 0, minus 6, plus 2, plus 4. Then you have 0, plus 4, minus 4. Then 2, minus 2, plus 0. Second row, first column. Now second row, second column. This is 4, minus 1, plus minus 2, sorry. And this is 0, minus 2, plus 2. Next, we have 2, minus 2, plus 0. 4, minus 1, minus 3. 0, minus 2, plus 3. This will be equal to 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, which is the identity matrix. So that means AB is equal to identity matrix, or AB into B inverse is equal to identity into B inverse, or A is equal to B inverse. Now the equations are x minus 2y is equal to 3. 2x minus y minus z is equal to 2, and minus 2y plus z is equal to 3. So according to that, if I transform that in the matrix forms, you have 1 minus 2 and 0. Z is 0. So 1 minus 2, 0. And 2 minus 1. Here Z is this minus 1. So 0 minus 2 and 1 into x, y, z is equal to 3, 2, 3. Which gives you, let's say, Cx is equal to D. So here you have C is equal to B transpose. Let's see the question once. See over here. AB to solve these equations. Okay, fine. So Cx is equal to D, or C is equal to B transpose. See how, what was B equal to? B matrix was equal to 1, 2, 0, minus 2, minus 1, and minus 2, 0, minus 1, 1. Question number 32. Now we are starting with section D. This section comprises long answer type questions of 5 marks each. So here you're given this is A matrix, this is B matrix. You have to find AB and then use that to solve these equations. Let's go. So here the A matrix is equal to minus 3, minus 2, minus 4, 2, 1, 2, and 2, 1, 3. B matrix is equal to 1, 2, 0, and minus 2, minus 1, minus 2, 0, minus 1, 1. Let's multiply. You have to find out A into B. Let's multiply. So you have first row into first column. This gives you minus 3 plus 4, 0. And first row, second column, minus 6 plus 2 plus 4. First row, third column, 0 plus 4 minus 4. Now, second row, first column, 2 minus 2 plus 0, 4 minus 1 minus 2, 0 minus 2 plus 2. Here you have a 2 minus 2 plus 0, 4 minus 1 minus 3, and 0 minus 2 minus 3, which is equal to 1, 0, 0, 0, 1, 0, and 0, 0, 1, which is identity matrix. This is identity matrix. That means AB is equal to identity matrix. If I multiply both sides by B inverse, so this is equal to this, or you have A is equal to B inverse. Right. Now let's move to our equations, which we had to solve using this solution. So equations are x minus 2y is equal to 3, or this gives me x minus, okay, I'll leave it as such. Wait. X minus 2y is equal to 3. This can be written as x minus 2y plus 0. Z is equal to 3. Second equation, 2x minus y minus z is equal to 2. This gives me 2x minus y minus z is equal to 2. As such, third one is minus 2y plus z is equal to 3. So 0x minus 2y plus z is equal to 3. If I represent this in the matrix form, this will be written as 1 minus 2, 0, 2 minus 1 minus 1, 0 minus 2, 1 into x, y, z is equal to 3, 2, 3. I can write this like this. Cx is equal to D. I'm representing this as C, this as D, and this as X matrix. Okay. Now you notice one thing. C is equal to B's transpose. How? B's transpose. How is that? See, B matrix was equal to 1, 2, 0, minus 2, minus 1, minus 2, 0, minus 1, and 1. And what is B transpose? This is 1, 2, 0, minus 2, minus 1, minus 2, 0, minus 1, 1, which is this matrix only. Right. So C is equal to B transpose. Let's multiply both the sides. I'll come back to this one. Cx is equal to D. So let's multiply both the sides by C inverse. You have this becomes identity matrix into X is equal to C inverse D, or X is equal to C inverse D. C inverse can be written as B's transpose inverse D. That is B inverse transpose into D. And B's, see, this is equal to B inverse was equal to A. So I will write this as A transpose D. So this is equal to your X. So X is equal to what was A's transpose? A matrix was, let's write minus 3, minus 2, minus 4. A matrix was minus 3, minus 2, minus 4, 2, 1, 2, 2, 1, 3. Okay, so what will be the A's transpose? I'm directly writing it over here. This is minus 3, minus 2, minus 4, 2, 1, 2, and 2, 1, 3. Into D, D was equal to, what was D? It was 3, 2, 3. Okay, so X matrix becomes minus 3 into 3, 9, plus 2 into 2, 4, plus 3 into 2, 6, minus 6, plus 2, plus 3, minus 12, plus 4, plus 9, that is equal to 1, minus 1, and 1 again. Okay, so X comes out to be this, which means you have X is equal to 1, Y is equal to minus 1, and Z is equal to 1. So this is answer for the A part of your question. That's it. You have this, X comes out to be 1, Y minus 1, and Z is equal to 1. Hope you understood this. Next is, let's solve the B part of it. If f of alpha is equal to cos alpha minus sin alpha 0, sin alpha cos alpha 0, and 0, then you have to prove f of alpha into f of minus beta is equal to f of alpha minus beta. Okay, let's solve the B part now. So you are given that f of alpha is equal to cos alpha minus sin alpha and 0. sine alpha, cos alpha 0 and 0, 0, 1. Here's a misprint. In this, it is 0, 0, 1. Right. And f of minus beta is equal to cos minus beta, sine minus beta, and 0. Then minus of sine of minus beta, cos minus beta, 0, 0, 0, 1. Okay. This is equal to cos minus beta is actually equal to cos beta itself, minus of minus sine beta. This is plus sine beta, 0. This is minus sine beta, cos beta, and 0, 0, 0, 1. Let's go to find f of alpha minus beta. That is equal to cos alpha. Wait. First of all, I'll find this. F alpha into f of minus beta. Let's solve that first. F of alpha into this. So I'll multiply those two matrices. Let's write down. You have cos alpha minus sine alpha 0, then sine alpha, cos alpha 0, 0, 0, 1. Let's multiply this with cos beta, sine beta 0 minus sine beta, cos beta 0 and 0, 0, 1. Let's multiply. You have now it's going to be long calculation a bit. You have cos alpha, cos beta plus sine alpha, sine beta. Here is cos alpha sine beta minus sine alpha cos beta and 0. This is sine alpha cos beta minus sine beta cos alpha sine alpha sine beta plus cos alpha cos beta 0, and here was 0, 0, 1. This is the formula for the first one, cos alpha minus beta. This is for sine minus sine alpha minus beta 0, and sine alpha minus beta cos alpha minus beta 0, 0, 0, 1. Right? And this is nothing but f of alpha minus beta. So you have therefore f of alpha into f of minus beta is equal to f of alpha minus beta. Hence, proved. Hope you understood this. Next is question number 33. Find the equations of the diagonals of the parallelogram PQRS, whose vertices are this, and this. You have to use these equations to find the point of intersection of diagonals. Or you have the second question as A line L. Okay, fine. We'll discuss that later. First of all, let's solve the A part. You have to find the equation of the diagonals of the parallelogram. Let's make that parallelogram first. This is the parallelogram. So this is the point P, which is having the coordinates as 4, 2, minus 6. This is Q, 5, minus 3, 1. R, this has 12, 4, and 5. And this is S, 11, 9, minus 2. So find the equation of the diagonals, whose vertices are these. Use this equation to find the point of intersection of the diagonals. First of all, you need to find the equation of the diagonal. So equation of diagonal PR, that is, you have P as 4, 2, minus 6, and R as 12, 4, and 5. X minus 4 upon 12 minus 4 is equal to y minus 2 upon 4 minus 2. Z minus minus plus 6 upon 5 plus 6. That's equal to x minus 4 upon 8, y minus 2 upon 2, z plus 6 upon 11. Let's say this is equation 1. Now let's go for equation of diagonal QS. Q had 5 minus 3, 1, and S was 11, 9, and minus 2. So the equation becomes x minus 5 upon 11 minus 5 is equal to y plus 3 upon 9 plus 3, z minus 1 minus 2 minus 1, or this is equal to x minus 5 upon 6, y plus 3 upon 12 is equal to z minus 3 upon minus 3. Let's say this is equation 2. Now you have to find the point of intersection of 1 and 2. Point of intersection of 1 and 2 is, see over here, I'll say from here, I will say x is equal to 8. If I'm putting this is equal to lambda, okay, I'll solve it here only. So from 1, you had x minus 4 upon 8 is equal to y minus 2 upon 2 is equal to z plus 6 upon 11 is equal to some lambda say. So here you have x is equal to 8 lambda plus 4, y is equal to 2 lambda plus 2, and z is equal to 11 lambda minus 6. So since both of these lines, 1 and 2, they are coinciding. That means they are having a, they are intersecting. That means they are having common x, y, z, right? So this x, y, and z which satisfy this equation as well, right? So I will fill that in equation 2. This will be filled in equation 2. So you will have 8 lambda plus 4 minus 5 upon 6 is equal to, this is from equation 2, 2 lambda plus 2 plus 3 upon 12 is equal to 11 lambda minus 6 minus 1 upon minus 3. This gives you 8 lambda minus 1 upon 6 is equal to 2 lambda plus 5 upon 10, 11 lambda minus 7 upon minus 3. So this will be 8 lambda upon this is equal to this. I'll solve this. I'll just pick up this pair. So that will be, now let's do the cross multiplication. 6 lambda minus 2 is equal to 2 lambda plus 5, or 14 lambda is equal to 7, or lambda becomes 1 by 2. For the point of intersection, lambda is equal to 1 by 2. So for the point of intersection, your x was equal to 8 lambda plus 4. So 8 lambda plus 4, that is equal to 8 into 1 by 2 plus 4, that is equal to 8. And y was equal to 2 lambda plus 2. So 2 into 1 by 2 plus 2, which is equal to 3. Z was equal to 11 lambda plus 6 minus 6, sorry. So this is 11 into 1 by 2 minus 6, which will be equal to minus 1 by 2. So the diagonal intersect at, this is the point, 8, 3 minus 1 by 2. So point of intersection of diagonals is 8, 3 minus 1 by 2. This is answer to the question. Hope you understood this. Let's move to the B part now. So I hope you are done with this. The point of intersection of the diagonals is 8, 3 minus 1 by 2. Let's go with this B part of this question that is in the choice. A line L passes through point minus 1, 3, minus 2 and is perpendicular to both the lines this and this. So find the vector equation of the line N, hence obtain its distance from the origin. Now B question is, the line L is passing through this point, right, and is perpendicular to these two. So first thing, fine, we are given that line is passing through this, perpendicular to this and this. So direction cosines, first thing, direction cosines of first line are I plus 2j plus 3k. Let's say this is equal to A. I'm talking about this line. And direction cosines of this was for the first line. For the second line, let's say that is B, is given by, this is for the first line, and direction cosines of second line, let's say that is given by the B, is minus 3I plus 2j plus 5k. Now let's find the cross product of them. That is equal to I plus 2j plus 3k multiply minus 3I plus 2j plus 5k. So that is written in the matrix form as I, j, and k, 1, 2, 3, minus 3, 2, and 5. Sorry, this is matrix determinant form. Okay. So that is equal to I 10 minus 6 minus j 5 plus 9 k 2 plus 6. So that is equal to 4I minus 14 j 8k. Right, that is equal to say A vector. Now the position vector of the given line is, see, according to this point, minus 1, 3, minus 2. Position vector of given line is B is equal to minus I plus 3j minus 2k. So vector equation of line is R is equal to B plus lambda into A vector. This gives you, this is R is equal to minus I plus 3j plus 2k plus lambda 4I minus 14j plus 0k. Right? Sorry, that's equal to A vector was this 4I, and this is 8k, not 0k. Okay. So this is equal to minus I cap plus 3j minus 2k. And I'll take 2 common from here. So this will be equal to 2 lambda, which is, see, constant itself. So 2I minus 7j plus 4k. This is the vector equation of the line. And this is one answer. You have to find out the vector equation of the line. We already solved that. Now let's find the obtain its distance from the origin. So that's very simple. Distance of line L, which is passing through the given point, that is minus 1, 3, minus 2, from origin is given by root of minus 1 minus 0 square plus 3 minus 0 square plus minus 2 minus 0 square, which is equal to 1 plus 9 plus 4, that is equal to 14 units, root 14 units. So we got both the answers. The distance came out to be root of 14 units. That's it. We have done question number 33 as well. Let's move to the next question number 34. Using integration, find the area region bounded by the line y is equal to root 3x and the curve y is equal to root 4 minus x square and y square in the first quadrant. Okay. First of all, let's make the figure to understand the problem here. So you are having the line y is equal to root 3x. Question number 34. Using integration, you have to find the area bounded by the line y is equal to root 3x and the curve y is equal to root 4 minus x square and y-axis in the first quadrant. Let's make the figure to understand the problem first. So first is the line is y is equal to root 3x. So this is a straight line. Let's say this is that line. This is a line passing through the origin. The second one is the curve y is equal to root 4 minus x square. This makes x square plus y square is equal to 4. So that's a circle, right? So you have to find it in the first quadrant. So I'll just make that part of the circle. The radius of the circle is 2, right? This is the radius of the circle. So this is somewhat like this. Fine. So this is the line y is equal to root 3x. This is y, and the x-axis, this is point 0, 2, and this is 2, 0. Fine. This is a line this. So say this is the point. I have to find the point of intersection. Okay, I'll do that later. And also the y-axis. So this is the area that you need to find out. Right? This line, this curve, and the y-axis in the first quadrant. You have to find the area bounded by this region. Okay. So now you have this equation and this equation. Let's find the point of intersection of these two. So you can say x square plus y is this is equal to 4. This makes 3x square plus x square is equal to 4, which gives you x is equal to plus minus 1. Since I'm considering the first quadrant, so I'll take x value is equal to 1. If x is equal to 1, y will be equal to root 3. So this is the point of intersection a, 1, 3. Now required area is given by 0 to root 3 of y upon, see, okay, y upon root 3 dy plus root of this. Now, how did you get these two things? Let's discuss that first. So, first of all, you have to find out the area which is occupied by this line y is equal to root 3. If this point is root 3, so this coordinate is given by 0, root 3, right? So this will be the area which is covered by the line y is equal to root 3x from 0 to 3. So this is from 0 to 3, y upon root 3 dy. This will be the x value. See, from here you have x is equal to this. And from here in the second equation, if I find out x square will be equal to 4 minus y square, or x will be equal to root of 4 minus y square. Now this area will be calculated from y is equal to root 3 to y is equal to 2. Hope you got this, like how I got this integral. So this is the required area. Now easy, let's find out the integral. 1 by root 3 will be taken outside, and y integral is y square upon 2. Limits are from 0 to root 3 plus this is given by y upon 2 root of 4 minus y square plus y upon 2 sine inverse. Y by 2 limits are from root 3 to root 3 to 2. Now you just have to fill in the values. That is 1 by root 3. This is 3 on 2 minus 0 plus 2 sine inverse 1 minus root 3 upon 2 minus 2 sine inverse root 3 by 2. This is equal to root 3 by 2 plus 2 sine inverse 1 is pi by 2 minus this, and sine inverse 3 pi by 2 is equal to pi by 3. So that gives you pi minus 2 pi by 3. Because this will cancel, and 2, this will be pi minus 2 pi by 3, which is equal to pi by 3 square units. So this is the required answer. We have to find out the area. So the answer is pi upon 3 square units. Hope you understood this. Next is question number 35. A function f, which is given from minus 4 to 4 to 0, 4 is given by fx is equal to 16 minus x square. Show that f is an onto function but not one-to-one function. Further, all the possible values of a for which f of a is equal to root 7. Now the first thing you have f is an okay, I'll start with first one-to-one function. So first of all, I'll go with, let's see whether the f function is one-to-one function or not. If it is a one-to-one function, then f of x1 should be equal to f of x2. That is, root of 16x1 square should be equal to root of 16x2 square, which gives you 16x1 square should be equal to this. 16 will cancel and you will have x1 square should be equal to x2 square, which is x1 square, x2 square is equal to 0. So this is x1 plus x2 into x1 minus x2 should be equal to 0. See, x1 plus x2, if I'm taking this is equal to 0 or this is equal to 0, here you have x1 is equal to minus x2. See, this is not possible. As if you are having, suppose x1 is equal to 4 and x2 will be minus 4. And over here, if x1 minus x2, question number 35, a function f defined from minus 4 to 4 to 0, comma 4 is defined by this function. Show that f is an onto function but not one-to-one function. You have to find all the possible values of a. Okay, for which f of a is equal to root 7. So you are given two things in the question. First, you have to show f is an onto function but not one-to-one. Also, you have to find the possible values of a for which this is true. So the given function is fx is equal to this for f is defined from this to this. Okay, now first thing, let's go for the 1 to 1 function. If I'm going from 1 to 1 function, you have, for that, fx1 should be equal to fx2. That means the root of 16 minus x1 square should be equal to root of 16 minus x2 square, or 16 minus x1 square should be equal to 16 minus x2 square. That is equal to x1 square should be equal to x2 square, or this should be equal to 0. Let's factorize. You have x1 plus x2 into x1 minus x2 should be equal to 0, which means either this x1 plus x2 can be 0 or x1 minus x2 should be equal to 0. See here, x1 plus x2 is equal to 0 is possible for if I take x1 is equal to 4 and x2 is equal to minus 4. So this is possible. Also, if I take x1 as, see, this is giving me x1 is equal to x2. This is also possible, like you can have the 4, 4 or any such type of values, right? But for 1, 1, 1 to 1, x1 should be equal to minus of x2, right? Therefore, fx is not equal, fx is not 1-to-1 function. Okay, let's go with the second part, that you have to prove that this is an onto function. So if I'm taking y is equal to 16 minus x square whole under the root, y square is equal to this, or you have x square is equal to 16 minus y square. So x will be given by this. So here x can belong to the interval 0, 4 only, which is true. Therefore, fx is onto function. That is it. We have proved that fx is not one-to-one function and fx is an fx is not one-to-one function and fx is an onto function. Now the second part of the question, you have to find out the value of a for which f of a is equal to root 7. F of a is given by root 16 minus a square is equal to this, which gives you 16 minus a square is equal to 7, or a square is equal to 9, which gives me a's value as plus minus 3. So a can have two values as plus minus 3. This is the answer to the second part of the question, right? So what was the value of a? Possible values, it is 3 and minus 3. Hope you understood this. Let's move to the next question, number 36. So, okay, here you have an engine displacement. Let's read about this first. Engine displacement is the measure of the cylinder volume swept by all the pistons of a piston engine. The piston moves inside the cylinder bore like this. Okay, up and down. Now, the cylinder bore is in the form of cylindrical circular cylinder. Open at the top is to be made from metal sheet of area 75 pi centimeter. Based on the above information, you have to answer the following questions. First one, if the radius of the cylinder is r centimeter, height is h centimeter, write the volume of the cylinder in terms of radius r. Okay, let's go with the first part. Here it is. Area of the metal sheet is area of metal sheet required to make a cylinder. Open from top, it is 75 pi centimeter squared. It's given. Now, R is the radius of the cylinder, H is height, right? Now the cylinder is open from the top. So cylinder is somewhat like this, right? First, you will get the curved surface area that is given by 2 pi R H. This is curved surface area plus the bottom surface area, which is equal to pi R square. This is equal to 75 pi. So let's solve this. I'll take pi R common. I have 2h plus R is equal to 75 pi. Pi and pi will cancel, or I'll open this 2hr plus r square is equal to 75, or 2hr is equal to 75 minus r square, or h is equal to 75 minus r upon 2r. Now, volume of cylinder formula, pi r square h. So pi r square into h is given by this. This and this will cancel. You have pi r upon 275 minus r square. That's it. You needed to find out the volume of the cylinder in terms of the radius, and this is it. Hope you understood. Let's move to the second part. Find dV upon dr. All right, this is easy because we already have the volume. So the second part says you are given V is equal to pi r upon 2 into 75 minus pi r square, 75 minus pi r square. dV upon dr is given by, I'll take pi by 2 common. So this can be written as d upon dr of this 75 r minus r cube. That is equal to pi by 2. I'll take it outside, 75 minus 3r square. That's it. This is the answer for the second part. Fine. Now the third part, find the radius of the cylinder when its volume is maximum. So you have to find out the radius of the cylinder for the volume is maximum. When volume is maximum, dV upon dr is equal to 0. That means pi by 275 minus 3r square is equal to 0, or 75 is equal to 3r square, which gives me r square is equal to 25, or r is equal to root of 25, which gives me r value is plus minus 5. So definitely it's not going to be negative. R will be positive only. So this is units are given. Yeah. This is 5 centimeters. The radius is equal to 5 centimeters. What you have to find out in the third part, find the radius of the cylinder when the volume is maximum. So the radius is 5 centimeters. Okay. Let's check it also. Let's confirm this thing also. Let's find the second derivative. You had the dV by dr as pi by 275 minus 3r square. So let's find the second derivative of it. You have pi by 2 minus 6 R, which is less than 0. Therefore, the volume is maximum when, let's put it a value of 5. So this is minus 30, which is less than 0. That means the volume is maximum at R is equal to 5 centimeters. Hope you understood this. Now the B part of it. This is the B part of the question. For the maximum volume, H is greater than R. Straight true or false and justify. Okay, for maximum volume, the B part of it, you had already dV by dr was given to you pi by 275 minus 3r square. For maximum volume, this is equal to 0, which gives you r is equal to, we already solved that, which gives you r is equal to 5 centimeter. We already solved this thing. Now, what was h? H was given by this 75 minus r square upon 2r. 75 minus r square upon 2r. This is 75 minus 25 upon 10. That is 50 upon 10, or that is equal to 5 again. So this is the value of h in this case. And what do we have to find out? H is greater than r. No, h is equal to r. So for the maximum volume, h is equal to r, 5 is equal to r. So this is false. Hope you understood this. Next, question number 37. Recent studies suggest that roughly 12% of the world population is left-handed. Okay. So depending upon the parents, chances of having a left-handed child are, let's understand this chart first. So right-handed and left-handed plus left-handed, like for every this, you have a left-handed parents, the probability that these are the right-handed kids, right hand, left hand, right hand, left hand, right hand, left hand for the father, right hand for the mother. You have these right hand kids, and both are having right hand. So this is the probability that you are having a right hand kids. So 12%, roughly 12% of the world population is left handed. Now, first thing is, depending upon the parents, the chances of having a left-handed child are as follows. Number A, when both father and mother are left-handed, chances of a left-handed child is 24%. So do remember this thing. When both are left-handed, the chances of having a left-hand child is 25%. Father is right-handed, mother is left-handed, chances are 22%. Father is left-handed, mother is right-handed, chances are 17%. Father and mother both are right-handed, the chances are 9%. Okay. Now, assuming PA is equal to B is equal to C is equal to D, all the probabilities are equal, and this is 1 by 4, and L denotes that the child is left-handed. So based on the above information, you have to answer P L upon C. Let's go. So first of all, what is PL? That probability of getting a left-handed child, it's given in the question that it's roughly 12%. So this is 12 upon 100, right? And probability of right-handed, which is not left-handed, will be equal to 88 upon 100, right? Now, you are given that all the four probabilities, that is P, A, B is equal to probability C is equal to D is equal to 1 by 4. And you had to find out probability L upon C. Okay, so first thing, probability of left-handed from A set is given by 24% it was. So that is equal to 24 upon 100. Probability of left-handed child from B set is equal to, similarly, that was 22%. Probability of left-handed from C set was equal to 17%, and probability of left-handed from D set is 9%. So very first thing, you have to find out probability from the C set, that is equal to this 17 upon 100. Next, PL upon A, we just calculated that also, that is equal to 24 upon 100. Sorry, this is PL dash. I missed that. So let's solve the B part. Probability L dash upon A is equal to probability L dash intersection A upon probability of A. Now this is given by probability of A minus probability L intersection A divided by probability of A. Probability of A was equal to, first this can be written as probability L intersection A upon P of A. Now this is equal to 1 minus, this is nothing but P L upon A. So that is equal to 1 minus PL upon A was this. So this is equal to 6 and 7. So 76 upon 100, right? That is 38 upon 50. Okay, so here you have this answer as 38 upon 50. Now the third part, PA upon L. This is given by PA intersection L divided by P of L. But you have a P L upon A that is equal to PA intersection upon L upon PA. And this was, this is equal to 24%. So 24 upon 100, PA intersection L and PA was equal to 1 by 4. So that is gonna give me 24 into 1 by 4 upon 100 is equal to PA intersection L. That is 3 by 50. Right? Now you had to find out PA upon L. Let's move to this. Basically, we had to find out PA upon L, which was given by PA intersection L upon P of L. 3 upon 50 and L was equal to 12 upon 100 because P of L, probability of left-handed people, was this. So this is 3 by 50 into 100 upon 12. That is equal to 1 by 2. So third option, third part, this is having the answer as 1 by 2. The same question, B part now, it says, find the probability that randomly selected child is left-handed given that exactly one of the parents is left-handed. Okay, you have to find the probability that randomly selected child is left-handed provided the condition exactly one of the parents is left-handed. Okay. So here is the B part. You have to find out probability of left-handed provided either B or C are true. That is B and C, exactly one parent was left-handed. This is equal to probability of left-handed intersection B union C divided by probability of B union C. This is equal to probability L intersection B union L intersection C divided by probability B union C. That is equal to probability L intersection B, L intersection C, L intersection B, L intersection C. This is whole divided by P B plus PC minus PP into PC. Okay, let's fill in the values now. So here you have this is 22 upon 100 plus, sorry, L intersection B. Okay, this is equal to 22 upon 100 multiply 1 by 4 plus 17 upon 100 multiply 1 by 4 minus 22 upon 400 multiply by 7 upon 17 upon 400 whole divided by 1 by 4 plus 1 by 4 minus 1 by 4 multiply 1 by 4. This is gonna give you 22 upon 400 plus 17 upon 400 minus 22 upon 400 multiply 17 upon 400 whole divided by 1 by 2 minus 1 by 16. So this is equal to 39 upon 400 minus 374 upon 116. 4 zeros will be there divided by this is 16 will be there and 8 7, right? This is gonna give you 16 upon 7 multiplied by 39 multiply 400 minus 374 divided by 1,16,000, 1,60,000, which is equal to 16 into 15226 divided by 7 into this. On solving, you will get the answer as 0.22. So that is it. You have this answer as 0.22. Hope you understood this question. Let's move to the last question of your paper. Use of electric vehicles will curb air pollution in the long run. The use of electric vehicles is increasing day by day, increasing every year. An estimated electric vehicles in use at any time t is given by the function v, which is given by this, where t represents the time, and that's equal to 1, 2, 3, corresponds to the year 2001, 2, 3, respectively. Based on the above information, you have to answer the following question. Now, first, can the above function be used to estimate number of vehicles in the year 2000? Justify your answer. Fine, you are given Vt is equal to 1 by 5t cube, 5 by 2t square, 25t minus 2. No function can be used to calculate the number of vehicles in 2000. No function can be used to calculate number of vehicles in 2000, as here t is equal to 1, 2, 3 and so on. Starting year is 2001, 2002 and 2003, so on. So therefore, it could not be used to calculate anything which is before 2001. That means this answer is no. Second, prove that the function Vt is an increasing function. For that, you have to find the derivative. So Vt is given by 1 by 5t cube minus 5 by t, 5 by 2t square plus 25t minus 2. Let's find the derivative with respect to t. You have 1 by 5 into 3t square, 5 by 2 into 2t plus 25. So this is 3 by 5 t square and 5t plus 25. Now the function is for the function to be increasing, for function to be increasing, the derivative, this derivative should be greater than 0. Therefore, 3 by 5 t square minus 5t plus 25 should be greater than 0, right? So let's look at this one. See, if I look at this function, 3 by 5t square minus 5t plus 25, and this is greater than 0. Therefore, fx, sorry, not fx, this was vt is an increasing function, right? Hope you understood this. So with that, we have completed all the 38 questions of this paper. Hope you understood them well and that was clear to you. I would like to go with the question whole over once again. You have to first, in the first part, you had to calculate, find out, can the above function be used to estimate the number of vehicles in year 2000? See, here T corresponds to 1, 2, 3, which 1 corresponds to 2001 and 2 and 3. Therefore, this cannot be used to calculate some information which is already not given in the given function. So the answer to the first part is no. Second, prove that the function Vt is an increasing function. So Vt was this. If I have to prove that this is an increasing function, that means its first derivative should be greater than 0. Let's find out the derivative. So derivative is 3 by 5 t squared minus 5t plus 25. This is greater than 0. This is an increasing function. Therefore, Vt is also an increasing function. Okay, so hope you have understood this well. We have completed all the 38 questions of this paper. A very best of luck for your exams. Keep exploring, keep scoring high. Best of luck. Do explore our website www.examsnet.com to practice many more papers or entrance exam question papers as well. You can also download our app. The link is available in the description box. So that's all for this paper. Hope you understood this well. Bye. Question number 38. The use of electric vehicles will curb air pollution in the long run. So here are some electric vehicles charging point. Now the question is, the use of electric vehicles is increasing every year. The estimated electric vehicles in use at any time t is given by this function, where t represents 1, 2, 3, corresponds to year 2001, 2002, 2003, respectively. So based on this information, you have to answer first question, can the above function be used to estimate the number of vehicles in year 2000? Justify this. Well, of course, the answer is no. And why is that? See, you are given this equation, right? And over here, the t represents 2001, 2, 3, and 4 years, so on. So no function can be used to calculate the number of vehicles which are previously defined. Starting here in the equation is 2001, so we cannot use this equation or function to calculate it before the data before 2001. So the answer is simply no. Let's write. The answer is no. The function cannot be used the function cannot be used to calculate number of vehicles before 2000 year. Because here the starting, the function has starting year given as 2001. Let's move with the B part. Now, prove that the function Vt is an increasing function. Vt function was given by 1 by 5t cube minus 5 by 2t square plus 25t minus 2. Let's find the derivative of it. V dash t is given by 1 by 5 3t square minus 5 by 2 into 2t plus 25. That is equal to 3 by 5t square minus 5t plus 25. Now for the function to be increasing, the first derivative should be greater than 0 for increasing function. Here you have 3 by 5t square minus 5t plus 25. This is greater than 0. That means Vt is an increasing function. That's it. So prove that the function is increasing. We just have proved that. So students, with that, we have completed all the 38 questions of this paper. Hope you understood them well. And don't forget to visit our website www.examsnet.com to explore this and many more entrance exam question papers which are very beneficial for you. You can also download our app. The link is available in the description box. So a very best of luck for your exams. Keep shining, keep rising high. Bye.